Hello guys, today we're going to study 4.2 logarithmic functions. The inverse function of the exponential function with base b is called the logarithmic function with base b. So here we have a formal definition of the logarithmic function. So you can pause this video to read it. Y equal to log base bx is equivalent to b to the y power equal to x. So we say this piece is a logarithmic form. And then we say there's a second piece right here that is exponential form. Example 1, write each equation in its equivalent exponential form. Okay, so first let's look at part A. So we have 2 equal to log base 5x. I'm going to write log base 5x equal to 2. Okay, so we're first going to write my constant to the right hand side. So then I'm going to have a 5, okay, then we say raise to the power 2 equals to x. Okay, if you can think of this as a snail, let's say put a little bit tail. Okay, not too bad. So I can write this as 5 to the second power, because we said 5 raised to the power 2, then equal to x. So we're just going to leave it in this form. So if you look right here, we have exponential form, so that's my goal, so that's why I don't simplify it. Okay, let's look at part B. So we're going to write this as log base b and 64 equal to 3. Again, all we have to do is we're thinking about this, the snail head, and then we have raised to the power 3 give you 64. So which means we can write this as b raised to the power 3 equal to 64. So that again is exponential form. So we're doing the same thing for part C. In this case, we didn't have to rewrite it, right? Again, we can do this. So that will give us 3 to the power y equal to 7. Again, the concept is exactly the same. Okay, so we're going to have the base and then raise to the power and then equal to something. Example 2 is changing from the exponential to logarithmic form. Part A, 12 to the second power equal to x. So what I'm going to do now, I'm just going to write this part, and then again, we're pretty much doing the similar stuff. Okay, so I can write this as log, remember that's the base 12. Okay, log base 12 x equal to 2. And then I have a part B. We have to b to the third power equal to 8. Again, the process is very similar. So that means we're going to have log base b of 8 equal to 3. Okay? So part C, we're going to have, so I'm going to write the original one out. Okay, so that means this is my base. So I'm going to write log base e of 9 equal to y. For example 3 is evaluating logarithm. Example 3, evaluating logarithms. So here we have, let's go ahead and look. So here we have a part A, evaluating. When you hear that, it means in the end you should have a number, okay, when we have evaluating. So if you look at this, we can set this up as what we have learned so far. Okay, we're going to have log base b, and then we have 16, and we're going to set this as x. What we're going to do is we're doing the same thing. Okay, let's snail, and I'm going to write it down as 2 raised to the power x give me 16. Then I have to think, okay, so can I rewrite this 16 as 2 to the what power? You realize 2 to the 4th power give you 16. So I compare those. That means my x is equal to 4. Right? So I can conclude this log base 2 of 16 is just going to be equal to 4. So let's look at part B. So now we have the similar illustration. So we have here we have a log base 7 of 1 over 49. I'm going to set it to x. So I can write this, I can rewrite this, alright? So that will be 7 raised to the power x equal to 1 over 49. Then I'm going to think, okay, 7 to the x. So what I can do is 1 over 49. So I realize that it's the same thing as 1 over 7 to the second power. Then I look at this, okay, 1 over 7 to the second power, which is a square. That's the same thing as 7 to the negative 2 power, right? So if some of you guys forgot this, maybe I can write it down for you. If we have a to the negative n power, just going to be equal to 1 over a to the n power. Okay, so since we have this case, we had a 1 over 7 to the second power, so that is equivalent to a, in this case is 7 to the negative 2 power, right? So that is the reason why I found this. So that's how I found it. So I'm just going to write it back. Alright, so then from here, I realize my x is just going to be equal to negative 2, correct? So my final answer, that will be natural log base 7 of 1 over 49 just equal to 2. Okay? Alright, let's look at part C. Part C, we have log base 25 of 5. We're going to set it to x. Okay, so we're going to have 25 to the x power equal to 5. And then I have to think, okay, so 25x, we want to write as the same base. Okay, in this case, we have 25, we have 5 on another side. So, but I do remember 25 is just going to be 5 squared. So this, I can rewrite it in this form, right? So once we have 5 squared and then outside the x, that's equivalent to, again, if you forget, so let's go ahead and go here. So in the past, we have learned a to the m power, the outside to nth power, just equivalent to a to the n power. Okay, so that's why we can follow this. That means give me 5 to the 2x power equal to 5. And then now we compare them. 5 is just going to be equivalent to 5 to the first power, right? So what happens here, so I can set those exponents equal to each other, and then I can solve it. That will give us x equal to 1/2. My final answer is log base 25 of 5 is just going to be 1/2. So on your test, please make sure to show work, okay? Without work, you won't get any points. So here we have part D. Let's do this really quick. We can set it to x. So I can rewrite this as 2 to the x power equal to 5th root of 2. So I can rewrite this, if you guys can recall, that's the same thing as we have this 2 to the first power. That will be 2 to the 1/5 power. If you have a hard time to remember this, okay? At least maybe you can remember this is just going to be a to the 1/2 power, right? Where that come from? This because here we have an invisible 1 and here we have invisible 2. That is where the 1 over 2 come from. And then that's the same concept, okay? Alright, so here the next step, if we have the same base 2, and then we're going to set the exponents equal to each other. That just tells us x equals to 1/5. We're going to write down our final answer, log base 2, okay, 5th root of 2, just equal to 1/5. Okay, let's go ahead and look at next. So here we have a basic logarithm property involving 1. So if you look at the first one, log base b of b equals 1. Okay, if you want to know why, so you can think b to the first power gave you b, right? If you think about it. Or you can think b to what power gave you b, then this must be equal to 1. That's where that 1 comes from, okay? For the second one, if you think about b to the what power gave you 1, hopefully you know b to the 0th power is just going to give you 1. Okay, so if you want to know why, that is the reason. Otherwise, you should just memorize it. Okay, and then let's look at the inverse properties for b greater than 0 and the b cannot be 1. So look at 3 and 4. We're going to say the log base b of b to the x power is just going to give you x. And then for number 4, b to the log base b of x just going to give you x. Okay, let's go ahead and look at how we apply those properties. So here we have example 4. So if you look at this, so hopefully you realize this is going to be property 1, right? This is b, this is b. So here basically they're same, so we're going to say this is going to be give you 1. So we use the property, I'm just going to write it down, property 1. And then let's look at the c. So here we have log base b and then b to the x power, right? This actually, if you match it, it's just number 3. So in this case, I'm just going to label this, that is my x. If you look at the yellow color, you should find that is your x. Or you can think everything else canceled. Okay, so let's look at the b. So if you look at b, that is just going to be property 2. So you're going to get 0. We're really just matching them. Okay, so then here we have the last one. That's just going to give you 9 because that is the property. Okay, this is the property 3 and then this is the property 4. Okay, I think have the graph of a logarithm function. Okay, from the beginning we talk about the inverse function of the exponential function. That was the logarithm function, right? So let's go back here, explain this. So you have to recall, okay, when we talk about inverse function, so here is that you have to consider that line as your basically your reflection. Okay, so here we have the, when we talk about base b, all right, so b is greater than 1. We talked about this last session. If we have a b is greater than 1, we said this everything is going to be climbing up, right? It's like climbing a mountain. So here we're going to going up. So that is, we have the first case, and then we have this graph, we have this reflection. Okay, so this blue color is reflection. And then if we have something here, so yesterday we mentioned, so b to the 0th power, it just give you 1. So that's why we're always going to have this passing this 0, 1 right here. So we have a 0, 1, and then we have this center right here, that is our reflection. So if you have a 0, 1, your reflection is just going to be 1, 0. You just switch your ordered pair. But let's say this point, we call it AB. The ordered pairs AB. That means on another side, on this side, we're going to have the point BA. Okay? That is the inverse function. That is our logarithm function. That's why it's so important you know how to graph exponential function, because if you know how to graph the exponential function, all you have to do is just change the ordered pair, then you get your logarithm function. So the same concepts apply here. If you look at the second graph right here, you're going to have b is between 0 and 1. In this case, we're just going to like a slide going down. Okay, look at the blue color. That is your exponential function. So again, here we'll have 0, 1. So right here is 0, 1. Then we're going to have 1, 0, right? So again, if we have something right there, let's call this, maybe we're going to use a different color right here. Round color. Let's use a rainbow color. So if we have this, it's A and B. And then remember, this is your reflection, right? This is your reflection. So that means reflect that. So it's around here somewhere. That must be your BA. Alright, so before we're doing the graphing, here we have the transformation, all the rules right here involving with logarithmic function. So I do want to mention, this is a lot to memorize. The last lesson we did exponential functions. So you have to remember those, you know, base b to the x, and then you have to plus c, all the things, f of x. Remember, you have to do this, right? So the thing is so many things to remember. So if you can just remember the basic rule, which I write right here, right? So if you can remember f of x plus c or minus c, that's just going up or down, okay? So in this case, your f of x is just going to be log base bx, okay? So that is what I'm talking about. This is your f of x. If you can just remember this general rule that actually apply for pretty much everything. That way you don't have to remember so many different transformations, because that's very confusing, I think. Okay? If you can just think your function just going to be log base bx. The last session, that was b to the x. That was your function. And then we here have a horizontal translation. So if you can think about this, right? If this is inside your function, your c is inside your function. So if you look right here, your c is inside your function. That's why you're moving the left. If it's a minus, you're moving to the right. Okay, horizontal shifting. And then the next is the reflection. Reflection is just going to be negative f of x. So again, in this case, your function is a log base bx. That's why you're going to have negative outside. Then thinking about is a lake. If we have f of negative x, that means you're going to have like a mirror in here. Okay, if you're a person right there, let's say that will be the mirror. Okay, so that's reflection about the y-axis. And then vertical stretching and the horizontal stretching is all same concepts. Okay, let's go ahead and look at how we do example 5. So example 5, we want you to do is to begin by graphing g of x equal to log base 3 of x. Then use the transformation to obtain the h of x equal to log base 3 of x plus 4. Okay? So first you got to remember what you have to do. You have to follow the directions. Because we said you have to begin by graphing g of x equal to log base 3x. So how we do that? So we said the logarithmic function is just the inverse of exponential function. So we must start with graphing f of x equal to 3 to the x power. Okay, so let's see why we have a 3, because the 3 is right there. Okay, 3 to the x power. Okay, let's make a chart. So I know always 3 to the 0th power is just going to give you 1. And then 3 to the negative 2 power is just going to be 1 over 9, because 3 to the negative 2 power is just going to be 1 over 3 to the second power, that is just 1 over 9. Okay, that is where that comes from. And then here, when we have negative 1, this is just going to give you 1/3. Okay, here we have a 3, and then here we have 3 squared, that's just going to give you 9. Okay, this is a couple points we found. So here we have the exponential function. Because we know the inverse function, we're just going to change our ordered pair. So now we can have our ordered pair for g of x. Use negative 2, and then we had 1/9, right? If I switch that, that means where our x is 1/9, and then our y, which is the output, is g of x, just going to be negative 2. So let's go ahead fill in the rest really quick. Okay, guys? So all I did is just switch your ordered pair. Negative 2, 1/9 become 1/9, and then negative 2. And then we switch all of them. Okay, once we have this, now we actually graph the log base 3x. So now we're going to graph the g of x. I'm going to plug these points really quick. Okay, and then I'm going to connect those points. Again, you don't have to do this long. Okay, so let's just do it until there. So we really don't need this another point for right now. So once you have this, we know this piece. Let's go ahead and write it down. So this is my g of x equal to log base 3x. Again, all we're doing is just follow the direction. By graphing this first, we did this piece. Okay, that's step 1. Once we have this step 1, then we said use the transformation to obtain this h of x. So this is the form, if I want to write it down right here. So that is the log base b x plus c form. So that means what? If you can't remember, you can go back to look at the chart. This means we're moving this to left. In this case, it's left 4 units. So then I'm just connect those points. Okay, so this is what after we moved. Alright guys, that is how you graph this h of x. So here we have your h of x equal to log base 3 and then x plus 4. Okay, so if the question asks you, which in your homework they ask you these questions. So let's treat this like a homework. So asking you what is the vertical asymptote, because for our basic function, here I can write this. Okay, this is your vertical asymptote for your g of x. Let me just write it down. So if you look right here, h of x, if you can think, all right, so this piece, okay, here actually is your new vertical asymptote for your h of x. Okay, so if you can count it over, that's just going to be what? X equal to negative 4. Okay, so that is my vertical asymptote. And then if they ask you what's your domain, so what is the domain of h of x? So again, domain, you gotta remember just from the left to right. So because we have vertical asymptote right here, so we can't pass -4, right? And then everything on the right hand side we can, is possible. So that's why we're gonna have from -4 to positive infinity. Because we only can get closer to the vertical asymptote, we can't actually touch it. That's why we have the parenthesis. So what is the range? Range is from the bottom goes up. Okay, so in this case we actually go down forever, right? And then we also go up forever. That's why your range is from negative infinity to positive infinity. Okay, that is how you graph this. Example 5 is very important. Okay, without showing work you can't get the points on your test, so please make sure you understand how to graph this. Okay, you graph your exponential function first, then you switch the ordered pair. Once you have the ordered pair switched, that will be your log base 3x. So once you graph that, then you're going to use a transformation. You're moving left 4 units. Okay, that is where the red line comes from. Okay, so here we also have a homework question. I have students struggle on this question. I'm just going to mention very quickly. Okay, so here we have the graph of a logarithm function is given. Match the graph to its function. Okay, so here we have a logarithm function already given to you, and then want you to choose one of those. If you look at this, the multiple choices, so all their base is 4. I don't have to put everything. Okay, so all there are 4. So the base is 4, which means our b is 4. That's greater than 1. Right, so we said if we had this basic graph, what's this basic logarithm function look like? That was, remember, you had an exponential function. Y equals to x is like your mirror. Okay, this is 0, 1, right? So you're actually gonna have this 1, 0. You just have to recall what you have done. Okay, then we said this piece that was our logarithm function, right? Let's say this is called g of x equal to log base b to the x power. So basically your green color, this is your logarithm function, right? And then you look at the graph right here on the right hand side, this graph. You look at this graph, this has to be some transformation. If you realize here, the original graph we had, I'm gonna just copy down on this. Okay, so that was my logarithm function, the original one, right? So here, if you look at this, what has changed? Hopefully you can see all this happens is we have this lake, or you can think this is reflection about your x-axis, so which means it's negative f of x form. So if you look, your function is logarithm function, the negative sign at the front. That's why this is your final answer. Okay, alright guys, thank you for watching the video. I'll see you guys next time.